This is a poison dart frog. It's really pretty blue. That's found in the New York City Zoo and in other zoos in the United States. This is PreAlgebra 2, Lesson 4.1, pages 156 through 161. Out of curiosity, what would you name this frog? I don't know. Never seen a blue frog before. So the first thing I want to do is let's look at whole numbers 1 through 50. And let's go through and cross out any multiples of 2 other than 2. We'll leave 2 alone. But we're going to go through and we would cross out 4, because that's 2 times 2. 6. We'd cross out 8. We'd cross out all of these. Okay. And then we would carry on with anything that basically ends in an even number, because we know that if it ends in an even number, then it's going to be divided by 2. So then we end up with, and then we can, let's see. So let's go through now and cross out all of the multiples of 3, but we're going to, like we did with the 2, we're going to leave that there. So we want to cross out any multiples of 3. I'll use a different color for that. So we'll cross out 9, 15, 21, 27, 33, and I'm not seeing anything off the top of my head here. Then let's check out, you get the idea, I don't have to go through them all. We could cross out all the multiples of 5. We've already got, see, that'd be 25. So that would be all of these. And we already got all of these marked out. And you can see then that we very quickly end up with what's called prime numbers. Numbers that can't be divided by anything other than 1 times themselves. 1 times 1, 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11, 1 times 13, 1 times 17, 1 times 19, so forth. These numbers are prime. So this is a chart of composite numbers. And composite numbers are whole numbers greater than 1 and itself, greater than 1, that has a positive factor other than 1 and itself. For example, up here the white spots show the prime numbers, numbers that only can be divided or multiplied, or only one goes, it's 1 and 5. That's the only factors you got there. 6, though, the pink ones show you which ones are composite numbers. So 4 we know is 2 times 2, 6 is 1 times 6, 2 times 3. So all the pink ones here show you that the numbers that can be multiplied by more than just 1. The only one, just for the information, is not a prime number and is not a composite number. Okay. So basically, 1, the chart could just be 2 to 100. So let's say that you have a class of 36 students who are going to take a field trip to the zoo, and the teacher wants to break the class into groups of the same size as they move around the zoo. How would you find all the possible group sizes? By writing all the factors of 36. So let's look at what the factors of 36 are. We have 1 times 36, 2 times 18, 3 times 12, 4 times 9. There is 5 is not 1. So we skip 5. We got 6 times 6. It's not, 7 and 8 are not factors. And then 9 times 4, and then you stop when the factors repeat. So we can say the factors of 36 are 1, 2, 3, 4, 6, 9. I already have 4 there. I already have 6. I already have 9. I don't have 12, 18, and 36. So those are the factors of 36. So now if we want to identify prime and composite numbers, let's look at 56. And we have 1 times 56, 2 times 28, 4 times 14, 7 times 8, 8 times 7, which is repeating, 14 times 4, 28 times 2, and 56 times 1. So all the factors of 56 are 1, 2, no 3, 4, no 5 or 6, 7, 8, we have 14, we have 28, and we have 56. When we come over to 11, we have 1 times 11, and that's it. So 56 is going to be a composite number. So this is a composite number, and 11 is a prime number. So now we have what's here. I have the whole number 24, and I have written, this is a picture of a factor tree. And when we express a whole number as a product of prime numbers, it's called prime factorization. And so you can see here with my diagram that 24 is 6 times 4, and then the 6 breaks down into 2 times 3, and 4 breaks down into 2 times 2. Now when we have multiple numbers, then we can use exponents. So we could say that 24 is 3 times 2 to the third power, because we have 1 2, 2 2s, 3 2s. So the prime factorization of 24 is 3 times 2 to the second power. So let's see what the factor tree for 30 is. We have 30. We have 2 times 15. We can factor the 15 out to be 3 and 5, and that's all we can do. So our answer would be 2 times 3 times 5. And so the prime factorization for 30 is 2 times 3 times 5. That's the most I can break it down to. And I don't have any exponents because each number is only used once. Let's see what 48 is. We would have 2 times 24. 24 breaks down into 4 times 6. That's 2 and 2. 2 and 3. So let's see how many 2's I have. 1, 2, 3, 4. So I have 2 to the 4th power times 3. And so the prime factorization of 48 is 2 to the 4th power times 3. Now 44 is a little bit different because I have 2 times 22 equals 44. And 22 breaks down only into 2 times 11. So now I got 2 2's, so that's 2 to the 2nd power times 11, and that would be the prime factorization of 44. 75, we have 2, and if you just always start with 2, it's going to break down from there. Most generally, not always, but most generally. That's 2, and that would be, you generally would have it. In this case, 2 isn't going to work because there's nothing, 2 isn't come up with a whole number. It doesn't divide into 75 as a whole number. So now let's go to 3, and 3, let's see what So we have 25. That breaks down to 5 and 5. So we have 2 5s, so it's going to be 5 to the second power times 3. So the prime factorization of 75 is 3 times 5 to the second power. Okay, so your assignment, which you can find in your textbook on page 159 to 161, you're going to do exercises 13 through 17, 23 through 31, 33 through 47, and 59 through 61. And your homework to take home is any of these exercises that you do not get finished in class. It is due tomorrow at the beginning of class, so you must take work home. There's no more spending 2 days doing it. Whatever you don't get done, you have to take home.